Hello everyone, my name is Avtar Singh. Welcome to my Java tutorials. Today I'm going to give you introduction to one of the most popular languages over the internet, that is Java. So let us begin. I'm going to teach you a course on Java. One of the first questions you should ask is that why should you learn Java? Well, first and the foremost reason is that it is very easy language. Believe me, once you get the hang of it, it's really easy. And it is in demand. Almost everything over the internet is based on Java. You can see it in your smartphones, you can see it on your laptops, you can see it on your Macs. It's almost everywhere you can imagine. Java is object-oriented programming language. What that means is that you can represent the real-world entities in form of objects. The object-oriented code is really easy to maintain and it's really easy to understand. Java has a lot of open source libraries. So, whenever you start a project in Java, you are sure to find something that other people have done and contributed to open source, which you can freely use. It gives you a lot of freedom, a lot of predefined things, predefined libraries that you can use for your project. So it's very helpful. And next thing is that Java is a platform independent. This is the reason, this is the primary reason, the platform independence that has made Java so popular. So let us look at this thing in a little more detail. What is the magic recipe for Java's platform independence? Well, the thing is that Java supports bytecode. Bytecode is highly optimized set of instructions designed to be executed by Java Virtual Machine. Well, that sounded rather robotic. Let us try to understand what I was trying to say. So, to understand the new approach of the Java, let us understand first what was the earlier approach. Earlier, there was the source code that was written by humans. For example, in case of C, C++, you have .cpp file, and then this source code went to compiler, which generated a machine readable file. This machine readable file was executed on the operating system, for example .exe files in case of Windows. So this was how the things worked. You had to provide the source code to the compiler. Compiler would generate a file that would be runnable on the machine. But this simple approach had some problems. First of all, that this compiler was dependent upon the machine. You had to write a different compiler for every architecture of the machine, well, which was not really possible when you consider the vast number of devices over the internet. One more thing, even if you were able to write somehow a compiler for each and every architecture over the internet, still you would have to provide the source code to your client so that they could compile your code and generate some machine readable files, which was really not the option, because that way they would be able to modify each part of your software and may even pirate it. So that was not good. Now, what Java did differently? Let us see Java's approach. Here also you have source code as usual, but this source code doesn't directly go to the compiler. It goes to Java interpreter. What Java interpreter does is that it produces bytecode. The source code files in Java are labeled as .java files. These are in human readable form. These are given to the Java interpreter, which converts them into .class files. Now these .class files are then further given to JVM, that is Java Virtual Machine. Now this Java Virtual Machine is platform dependent, that is you have to write Java Virtual Machine for each and every operating system or the architecture over the internet. But the advantage is that .class files are executed over JVM without further modification. What that means is that once .class files are produced, then they could be run on any JVM machine. You don't have to optimize your code for any other device. Instead, you just have to write a JVM. That's all.